Hi friends, welcome to my another video. Today in this video, I will discuss how to select the ELR rating for a particular motor or load. The question is, suppose this motor is 10 HP motor, then what would be the ELR rating for this 10 HP motor? And suppose if this motor rating is 500 HP, then what would be the ELR rating for that motor? You can consider this discussion is for any kind of other load also. It is not limited to the motor only, but for simple explanation, I will keep it the load as a motor. In one of my previous video, I have already discussed that the earth leakage relay is used to protect the human or stray animal from the earth leakage current shock. If you want to know in deep about the ELR, then watch my video, difference between ELR and EFR, that is the difference between earth leakage relay and earth fault relay. For this video, just you understand that the earth leakage relay is used to, the purpose of earth leakage relay is to protect the human and stray animal from the earth leakage current. The purpose of installing the earth leakage relay is not to protect the equipment. The purpose is to protect the human and stray animal from the earth leakage current. But by protecting the human from the earth leakage current, the byproduct came that it is protecting the equipment also. But the motto is not to protect the equipment. For protecting the equipment from the earth fault, there is already one type of relay available, that is earth fault relay. So hope you understood till here that the purpose of earth leakage relay is not to protect the equipment, but to protect the human. But during protecting the human, the earth leakage relay is protecting the equipment also. Let me elaborate this one to avoid this confusion. Suppose there is a motor, okay, and there is a earth leakage protection scheme, that is ELR, feeding this motor. During the earth leakage fault, during the normal condition, suppose 100 ampere of current is flowing through this motor. So in each phase there is a 100 ampere of current. But due to earth leakage condition, then what will happen? Suppose 90 ampere of current is flowing through the R phase, because there is a earth fault happen at the R phase, and in Y phase and B phase there is 100 ampere of current flowing. So the motor will encounter with the imbalance current. Due to this unbalanced current in the motor, of course it is a very slight unbalance, but due to this unbalance, the motor will try to draw more current from the other phases, and due to that the motor get heat up. And if this unbalanced current will be for longer time, then due to continuous heating of the motor, the winding insulation of the motor will burn and it will cause the short circuit inside the motor. But here the earth leakage relay is tripped whenever it finds that there is a earth leakage current to protect the human. But suppose if this earth leakage relay is not there, then continuously the motor will encounter with the unbalanced current, and it will draw more current from the other phases, and due to which the motor gets short circuited or motor get overheated, and the overheating of course will cause some problem in the motor. But due to the earth leakage relay will trip in order to cut the motor from the power supply. But this tripping of the circuit breaker through ELR is not to protect the motor. It is always to protect the human, as this 10 ampere of current may cause the death to the human. So ELR will trip in order to stop this 10 ampere of current which is flowing to the ground. Hope you understood the main purpose of ELR, and of course during complying the main purpose of ELR, that is to protect the human, it is giving a byproduct which is also good for the equipment. Now let us take another example. In previous case, the current which is drawing by the motor at full load condition was 100 ampere. But let us take this time the current which is taking by this motor is 1000 ampere. Just take an example, 1000 ampere. And suppose in this case the earth leakage current due to the earth fault is 20 ampere. So after the earth fault, the R phase will have a current of 980 ampere. Okay, for this motor the R phase will have a current of 980, B phase, Y phase as 1000 ampere, B phase 1000 ampere. For this motor, this slight imbalance is not a problem because it is very less as per its full load condition. But this 20 ampere of current is very high for a human. If this 20 ampere of current will pass through a human body, the death of human will be certain, very certain. From these two examples, we can conclude that when the load rating is very high, then the small unbalance in the load is not that severe to that load, as the full load current of that load is very high. But this small leakage current is not that harmful for the equipment, but very, very harmful for the human. As the main purpose of ELR is to protect the human from this leakage current, then the earth leakage relay should trip the circuit at very minute amount of earth leakage current, though the rating of the load is very high. It meaning that the earth leakage relay is not caring how much current is taken by the load. The earth leakage relay is caring that how much leakage current is flowing at the earth leakage fault condition. So it will trip the circuit in order to protect the human. I hope you got this. This concept is very important to understand how to select the ELR rating for motor or for any load, as there is no any straightforward calculation to select the ELR. This concept is very important to select the ELR. What I said so far, that ELR purpose is to protect the human. So ELR will not care about the load, that how much current the load is taking. The ELR will care about how much current is leaking. And if the leakage current is more than the dangerous level that can harm the human, then it will trip the circuit. Hope I am clear till here. After understanding this concept, let us understand and let us overview about the earth leakage relay. The earth leakage relay has two major settings, that is for the earth leakage current setting and the time setting for that earth leakage current. Okay, different ELR will have different range of earth leakage current rating. Suppose, for example, this ELR have a earth leakage current setting from 0.03 ampere to 30 ampere, meaning from 30 milliampere to 30 ampere, which is very wide range. And the time setting is from 0 second to 4.5 second. In case of this ELR, you can see that this ELR has the setting for the current till 8 ampere and the time setting is from till 3 seconds. Let us check another ELR. If you can see here, this ELR have the earth leakage current setting from 0.03 ampere to 30 ampere, as same as this ELR, and the time setting is from 0 to 10 seconds. This ELR, if you can see that the ELR having a setting, maximum setting for the earth leakage current is 30 milliampere into 100. This is the multiplier. So it will again come 30 ampere, and the time setting is still 3 seconds. 3000 millisecond means 3 seconds. From this discussion, one important point need to observe that in none of the ELR there is a rating for the load, meaning for which rating of load this ELR can be used. When we are selecting any RCCB or ELCB, then we find two types of rating. One, the contact rating, maybe 63 ampere, 40 ampere, 32 ampere, 20 ampere, which will show that the maximum load current which is going to be fed by this ELR or by this ELCB or RCCB is 63 ampere. And there is another rating which is called sensitivity rating. It can be 30 milliampere, 100 milliampere, 300 milliampere, and this current will inform that this ELCB will trip if this ELCB or RCCB will find a leakage current of 30 milliampere or 100 milliampere as per the sensitivity rating. But in the ELR you didn't find this rating, the load rating. This is very important thing to observe. In the ELR, you will not find anywhere the load rating for which load this ELR can be used, or for which load this ELR can be used, or for which rating of load this ELR to be used. This is very important to observe to understand this concept, that how to select the ELR for a load or for a motor. Because as I told you in beginning, there is no direct formula to calculate the ELR rating for the motor. Unlike RCCB and ELCB, the ELR only have the sensitivity rating and ELR do not have any contact rating, or you can say the load rating. Let us understand why the ELR do not have the load current rating unlike RCCB and ELCB. In case of ELCB or RCCB, you can see that whatever the load current required, this current has to be carried by the RCCB. From this diagram, you can understand it very easily. Whatever the load current is required, this current is flowing through the RCCB. That's why the RCCB has both rating, the sensitivity rating and the maximum load current rating. But in case of ELR, you will find that the ELR is taking all the feedbacks from the CBCT and the CBCT is dealing with the load current. Of course, if the ELR is not dealing with the load current, then the rating of the load is not required for the ELR. Now our focus will be to select the CBCT rating as the CBCT is dealing with the load current. So the topic which we started, that how to select the ELR rating for a motor or load, now shifted to how to select the CBCT rating for a motor or load. So let us analyze the CBCT, and depending upon our analysis, we will select the rating for the CBCT as per our load. In order to understand this one, let us understand first the operation of CBCT, which I already explained in my previous video, but I will overview here to understand it more clearly. In CBCT, what we do, we will pass the line conductor for 3-phase system and line conductor and neutral conductor for 4-phase system, and line and neutral for single-phase system. We will not pass any earthing wire through the CBCT. This is the additional knowledge. It is not required for this topic. Now, what CBCT will do, suppose there is a load here connected and this is the source side. The current will flow through these cables and these cables will pass through the CBCT. In normal condition, meaning in no fault condition, no earth leakage fault condition, whatever current will flow through R, Y and B, the phasor sum of all these three current, IR plus IY plus IB, will be always equal to 0. Why it will be always equal to 0? Because these all three currents are 120 degrees shifted from each other and the phasor sum will be always equal to 0. But suppose an earth fault happen, okay, then some current will flow through the earth leakage path and then to the ground. Then in that condition, the phasor sum of this three current, that is IR plus IY plus IB, will not be equal to 0. As the resultant current is not 0, then this resultant current will produce the magnetic field in the CBCT, and due to this magnetic field, an induced EMF and induced current will occur in the CBCT, and this current will go to the earth leakage relay which is connected with the CBCT terminals, and due to this current which is occur due to the earth leakage fault, earth leakage relay will trip the circuit breaker or contactors. So now let us take two examples and then we will analyze this CBCT response. Suppose in first condition, there is 50 ampere of current is flowing from the source to the load through CBCT and the condition is normal, there is no earth leakage fault. Then the phasor sum of all the current at every instant is equal to 0. So the CBCT will not get any induced EMF as the resultant current passing through the CBCT is 0. Now let us take another case that this time 1000 ampere of current is flowing through each phase. In first case there was 50 ampere of current. Now in second case the 1000 ampere of current is flowing through the CBCT and it is a normal condition. So again the resultant current in the CBCT is 0 as the phasor sum of each current at any instant of time is always 0 in the normal condition. So again the CBCT will not get activated as the resultant current is 0 and this load will function. What we observe from these two cases is that whatever be the load current, it is 50, 100, 200, 500, 1000, 5000 ampere, the CBCT will be inactive in the normal condition. So the CBCT is not caring about the load current, how much load current is passing through the CBCT, as the resultant current passing through the CBCT is always 0, though there is a 5000 ampere of current is passing through each phase. What we conclude from this discussion is that until the system is healthy, until there is no earth leakage fault in the system, CBCT also not caring how much load current is passing through this CBCT, as the CBCT is only caring about the difference in the phase current. In the normal condition there is no difference in the phase current, so CBCT is not caring how much ampere of current is passing through it. Hope you understood till here. Now let us take another case in this time there is a earth leakage fault happen in the B phase, line 3 phase, okay, and R phase and Y phase is healthy. Then what will happen? The resultant current is this time after the earth leakage fault condition is not equal to 0. This will induce the EMF in the CBCT as there is a difference in the phase current, and this will trigger the ELR to trip the circuit. Now let us take another case. Suppose this time not 50 ampere but 1000 ampere of current is flowing through each phase, and again the fault happened to the B phase, earth leakage fault happened to the B phase. In first case there was 5 ampere of current was flowing as the total load current is 50 ampere. So the leakage current also will be less. And in another case, now the total load current is 1000 ampere from each phase, then the leakage current will be more. Suppose this time 50 ampere of leakage current is flowing at earth leakage fault condition. So this time also CBCT will find the difference in each phase, but this time the CBCT will be encountered with the higher difference in the phase current compared to the first case. Don't take me wrong from this discussion. Even when the load current is 1000 ampere, the leakage current possible of 5 ampere also. But when the load current is 50, the possible leakage current cannot be 50 or more than 50 because the total current from required for the load is 50. So even if there is a earth leakage fault happen, the maximum current that can flow to the ground is 50. So it cannot go for 60 ampere. But in case of when the load current is high, let's say 1000 ampere, then there is a chance to flow 5 ampere, 6 ampere, but there is a chance to flow also 50 ampere or 60 ampere earth leakage current. This leakage current is not depending on the load current, it is depending on the insulation failure. How much degree of insulation failure happen, that much amount of current will flow as a leakage current. Suppose in case of 50 ampere, the insulation failure is more, then in this case maybe 30 ampere of leakage current is flowing. But when the load current is 1000 ampere and the degree of insulation failure is very minute, then only 5 ampere of leakage current is flowing. That can be also a case. So the conclusion of whole discussion is that the leakage current is not depending on the load current, it is depending on the degree of insulation failure. But of course, if the load current is high, then due to the severity of the insulation failure, the leakage current will be high. Now let us move further. Suppose this ELR I delta N rating, that is the leakage current rating, is set on 1 ampere. Now first case, there was 50 ampere of current is flowing through each phase of the wire or of the cable, and there is leakage fault happen in one of the phase, let's say in B phase, and there is a 5 ampere of leakage current flowing through the earth leakage fault. Now what will happen? The CBCT will sense there is a difference in the phase and it will trigger itself and it will give feedback to the ELR. Now as the fault current is 5 ampere and the ELR is set at 1 ampere, then the ELR will give signal to the circuit breaker, sun trip coil, or to the contactor to trip the circuit as the fault current is more than the set current of the ELR. Now suppose in same case 50 ampere is a load current and this time 15 ampere of current is flowing as a leakage current. Again the CBCT will find the difference in the phase current due to the earth leakage current. Again it will give response to the ELR, and ELR, as the ELR is set on 1 ampere, it will trip. So what we observe from here, whatever be the fault current, if the CBCT is sensing the difference in the current and giving feedback to the ELR, if that feedback current is more than the preset value, the ELR will give signal to the circuit breaker or to the contactor to trip it. Now you understood till here, I hope. Now let us say in this time 1000 ampere of current is flowing through the load, and this time the earth leakage happens, let's say 50 ampere. In this case again the CBCT will find the difference in the phase current. Of course this time the CBCT will find more difference compared to two previous cases, and this difference of current will trigger the CBCT. It will give feedback to the ELR and ELR will trip when as the setting is in the 1 ampere and the fault current is 50 ampere. But wait, here there is a one twist. CBCT all the time giving response to the ELR even if there is a 0 ampere of current. Means if the CBCT is not activated, this is also a command to the ELR that the CBCT is not activated. But as there is a current increases that more than the ELR current, ELR setting current, let's say 1 ampere is set on the ELR, as the CBCT sends more than 1 ampere of current, it will give signal to every fraction of second and it will trip the circuit. Whether there is a difference of 50 ampere, 100 ampere, 200 ampere of current, as the CBCT sends more than 1 ampere of current, it will give signal to the ELR and ELR will trip. To better understand this concept, let us change the setting of the ELR. This time, now the dial is set on 30 ampere. Now, suppose the load current is 50 ampere and there is a earth leakage fault current is 1 ampere. Then CBCT will give response to the ELR that there is a 1 ampere of leakage current. But ELR will not trip as the setting of the ELR is on 30 ampere, which is more than the earth leakage current which observed by the CBCT. Now suppose same condition, 50 ampere of the load current and this time 31 ampere of current coming as a leakage current. Then again CBCT will give command to the ELR. ELR will sense that it is a more than 31 ampere, more than its preset value, and it is stripped. Now let us take another case that this time 1000 ampere is the load current and 80 ampere is the leakage current. As the CBCT sends more than 30 ampere of leakage current, then it will reach to the ELR and ELR will trip the circuit. So ELR will break the circuit. In that condition, the leakage current will become 0 as the circuit is already broke. What we conclude from this discussion is that suppose if the ELR is set at some point, let's say 10 ampere, then the CBCT is sensing the difference in the current 10 ampere, and as it is going above it, the circuit breaker will trip and the leakage current becomes 0. Suppose if the earth leakage fault current is supposed to be 250 ampere, but as the leakage current on the ELR dial is set at 10 ampere, the CBCT will sense only 10 ampere and slightly more than 10 ampere. As it is reaching to the ELR will trip the circuit, and whatever would be the fault current, let's say 250 ampere, it won't be reached till that level as it is circuit is broken and leakage current become as a 0. Hope you understood. Now what we conclude from all this discussion, we see that in our previous discussion that the ELR is not depending on the load current, first thing. Second thing, when the circuit is normal, there is no leakage current, then that time also the CBCT is not depending on the load current. Third thing, what we discuss and what we conclude that at the fault condition, at the leakage fault condition, the CBCT is not caring how much would be the leakage current, as at the whenever the leakage currents reach to the preset value of the ELR, it will trip the circuit. Hope you. So here we concluded 3 points. ELR is not depending on the load current. CBCT is not depending on the load current in normal condition as well as in the fault condition. So our question is still valid, that how to select the ELR rating for a particular motor or for a particular load, as the ELR and the CBCT is not depending on the load current in healthy condition as well as in the faulty condition, earth fault condition. It is completely depend on how much protection you need from the earth leakage. Suppose you want to trip your circuit at 1 ampere leakage current, then you have to select an ELR which have a range till 1 ampere or above, as you have a convenient or you have an option to select at 1 ampere. If you want the system to trip when there is a earth leakage current of 30 milliampere, then select an ELR which having a setting till minimum at 0.3 ampere or 30 milliampere. And how fast you need the circuit breaker to trip, in that way you have to select the range of the ELR in time basis. This is the general thing. Now you might have one question in your mind, then why the CT ratio, CBCT is ratio given as 50 by 1, 100 by 1, 200 by 1, even sometime you will find 25 by 1. Then suppose this ELR is set on 5 ampere, okay, and we use a CBCT of 25 by 1. What does it mean? It meaning that when there is a 25 ampere of difference in the CBCT, then the induced current in the CBCT will be 1 ampere. But the ELR is set on the 5 ampere. As the CBCT sends 5 ampere of difference, then the ELR will trip the circuit, and that time 0 ampere of current will flow through the circuit as the circuit is broken. Though there is a CBCT, though the CBCT has a range to check the difference till 25 ampere of current, but as the ELR is set at 5 ampere, the CBCT will not reach, as the ELR will trip the circuit and the leakage current will become 0. Now let us check another case. In this case, the setting is in 30 ampere and this 25 by 1 CBCT we use. Then, and the leakage current is 30 ampere, more than 30 ampere or 30 ampere. Then this CBCT will fail to operate this ELR, as the core of this CBCT will saturate at 25 ampere difference in the current, and it will give only 25 ampere of phase difference or leakage current signal to the ELR, and as the ELR is set at 30 ampere, then the ELR will not trip, though there is a more earth leakage current in the circuit. Now let us take another case, and after that we will summarize this video. Suppose we took a CBCT of 200 by 1 ratio, meaning when there is a 200 ampere of difference in the current, not load current, difference in the phasor current, then 1 ampere of current will induce in the CBCT coil and it will give signal to the ELR, and it will indicate that 200 ampere of leakage current occur in the load side or in the circuit. But as the ELR is set on 30 ampere, as the leakage current reaches more than 30 ampere, the ELR will trip the circuit and again the leakage current becomes 0. Meaning, as the earth fault happen, it means the prospective fault current that can go till 200 ampere, but it will not go, as the leakage current, the set leakage current in the ELR is 30 ampere. So there is no use of selecting 200 by 1 ampere, as your set current is 30 ampere. Your 50 by 1 ampere CBCT is enough. So what we have to do is, you have to select one higher rating of the CBCT as per your selected range of the ELR. If it is less, I told you what would be the case if we will select one lesser rating, but this rating also not depend on the load. Even the load is carrying 500 or 400 ampere of current. If you select a 50 by 1 CBCT, it is enough to trip the circuit. Even it has a 4000 ampere of current in the load, 50 by 1 CBCT is enough for this ELR to trip the circuit. So what is the idea to select a CBCT and ELR for a particular load? The simple idea is how much protection you need. Accordingly, you have to select the ELR which have that range and the CBCT range. Here is one technical data sheet for the core balance current transformer, that is CBCT. Here you can see that the network current IPN is 1 ampere to 4000 ampere, meaning this CBCT we can use for a load of 1 ampere to 2 ampere, 2000 ampere, till 4000 ampere. Okay, and the secondary current is still 10 ampere, meaning if we are going for such CT, then we have to select an ELR having a range till 10 ampere of leakage current, and we can use any load as the range is 1 ampere to 400 ampere. As I told you, the CBCT rating and the ELR rating is not depending on the load current. I hope you understood this concept. I know it is a very difficult to understand as it's required too much concept, but I try my level best to simplify this topic. Suppose if someone will ask you that you have a motor of 100 HP, then what ELR you need, and if you have a 500 HP motor, what ELR you use, then you can say that same ELR I can use for both of the rating, as the load current is not depending on the the ELR rating is not depending on the load current. Just you have to take precaution that how much protection you need, how much earth leakage current you need to break. That range of ELR you have to select, and one higher range of CBCT you have to select. And if you are selecting first the CBCT, then go one lower range of ELR. That is the thing, means for any load, 100 HP, 150 HP, 200 HP, 300 HP, one same ELR can work for other different range of motors. Hope you understood this video. If you really got some good information from this video, then please do subscribe my video, like to this video, and react on the comment section, so I will know that how my video is for you all guys. Thank you so much. We will meet in any other video. Till then, take care, keep learning, and bye bye. Thank you so much.